Good morning, viewers. I am Saraswathi, working as a assistant professor. Now, we are going to discuss about the topic is deadlock. For example, the transaction T1 hold the relation student. The transaction T2 hold the relation grade. The transaction T1 requires the another relation grade, which is hold by the transaction T2. With the transaction T2, which requires the relation student, which is held by the transaction T1. That is, if the T1 will access grade, but a T1 hold student. If the T1 access grade means when the T2 will release the relation grade, then only T1 will access. Same like that, the transaction T2 hold the relation grade and the transaction T1 hold the relation student. If you are requesting the relation student for the transaction T2, then T1 release the relation student. This will be a cyclic. It automatically form a cyclic or circular. This method is called as a deadlock. Deadlock is a DBMS is an undesirable standstill situation. More than one transaction waiting for indefinitely for each other to release the lock. It causes the transaction to freeze, it preventing them from finishing. This is a mind map of a transaction. A transaction is a mutual exclusion, hold and wait, and no preemption, circular wait. These are the conditions of a deadlock. It's a blocked transaction, narrow road analog and standard protocol. The conditions for a deadlock. There are four conditions for a deadlock: mutual exclusion, hold and wait, no preemption, and circular wait. Mutual exclusion is the T1 hold the resource R1, T2 hold the resource R2. The T1 requires the resource R2. The T2 requires the resource R1. R1 is available in the transaction T1. The R2 is available in the transaction T2. If you are releasing on transactions and then only which is used by the another transaction T2, it will form a cycle. If you are mutually agreed and mutually allocated for the resources R1 and R2 based on the priority and first come first basis, the resources will be allocated for that given transaction. Hold and wait is if the transaction T1 hold the resource R1. Now R1 which hold the transaction T1, but T2 which requires the relation R1. If T1 complete that operation, up to this T2 will be wait. This hold and wait concept. Circular wait. None of them will be blocked. That is, more than one transactions will be blocked. It goes to a indefinite state. It's a give or a practical example of a deadlock. The supplier hold a lock on a supplier. The part hold a lock on a part. The supplier want lock for a part, but a supplier want a lock for a part. The part wants to lock on a supplier. If the supplier release the lock, then only the part will be used. The part will release the lock, then only the supplier will be used. Both are will be blocked. This situation is a deadlock. The deadlock prevention algorithm. This condition can be avoided by using the uh, methods, prevention method. At least one among the deadlock condition is to be denied. Only the particular transactions will be accessed. How the resource is to be requested by the process. Load device utilization, reduced throughput. Avoidance. To decide whether the current request can be granted or not. The resources can be used on the priority and first come first service. Resources currently available is allocated to each process. The future request and release of each process. Deadlock recovery. The optimistic method and pessimistic method. These are the two different approaches in recovery method. An optimistic approach, rollback and preempt the resources. Pessimistic abort or abort one process will deadlock eliminated. About all the deadlock eliminated process. Practical examples in application. The process A will hold the lock X lock and the process B which requires the lock B lock. The customer table. The lock will be contains the table customer table. John and Peter. This are two type of customer. John update the transaction to the process A. And the Peter select by using a select command to view the result. That result will be stored into the customer table after the updation of John. The John update the value of that process A. The update process value will be stored in a customer table. The value will be reflected into the another customer Peter by using a select command. Assessment. Which of the following is not a necessary condition for a deadlock? Starvation is not a deadlock. It's a potential result. The Banker's algorithm used in deadlock avoidance algorithm. These are the references. Thank you.